at Islip Airport. We're a pretty big repair shop. We work on corporate aircraft, and we fix almost 60,000 different parts. Generators, starters, pumps. One of the interesting things we work on are inertia switches. This little glass capsule right here. And it's adjusted for 6 Gs, 6 times the force of gravity. It's in the plane, and what it does is if the plane has a minor crash or bumps into a mountain, it turns on the emergency floor lighting. So it's nice to know the floor lighting is going to go on because of this. So we have to figure out a way to legally test it according to the repair manual. This is an FAA certified test rig. It's got a little sticker on it, but the FAA has certified this Rube Goldberg setup is good enough to test these aircraft crash switches. And after we test it, it gets a yellow tag that says it's been tested and it's airworthy and can be installed. So we had to make a centrifuge to properly test it, and just do some basic quick math. It's supposed to trip at 6 times the force of gravity. Gravity on Earth is 9.8 meters per second squared. I shouldn't have to tell this audience that. Do the math, times 6 Gs, comes out to 59 meters per second squared. And to figure out our centrifuge, centrifugal force equals the velocity squared of the switch as it spins divided by the radius. So we made the radius a nice, good number so that the circumference is 1 meter. It helps us with the math. So we get 59 meters per second squared equals the velocity squared divided by the radius. Do the math and it comes out, velocity squared comes out to 9 meters squared second squared, and the square root of V is 3 meters per second. So our crash switch has to rotate 3 times in 1 second before it trips. So we hooked up a little flashlight bulb and a battery to it, and we got an electric drill that's been locked in the on position, and we have a variable transformer, sometimes called a variac, and we can vary the line voltage from the wall from 0 to 110 volts, so we can slowly bring up the speed of the drill. And when it hits a particular speed, the light bulb should come on. Now, to measure the speed accurately, we put a 60-tooth gear right under the arm, and we have a speed pickup right here. There are dozens of these speed pickups on aircraft. Let's see, right here, speed pickup. It's basically a cylindrical magnet, very small. It's got a coil of wire wound around it, and it goes to our multimeter, which measures volts, ohms, and it has a frequency setting as well. So it will measure the pulses coming out of this little magnet. Every time a gear tooth goes past the magnet, it upsets the lines of force and sends a little pulse through the coil. This is also pretty much the same exact thing that's in every electric guitar. A 6-string guitar has 6 of these, 1 under each string, and the string will upset the magnetic lines and send it to the guitar amp. Same thing in your car. The ignition in your car, if you have a 6-cylinder car, there's a 6-tooth gear in the distributor, and every time the gear tooth goes past the speed pickup, it fires a spark plug. So these speed sensors are all through the industry. Anytime there's something turning and you need to monitor the speed, this little speed pickup is what does it. On an aircraft, this little speed pickup's about $300. At our warehouse, we have a huge warehouse, and I get to play with these toys every day. I have some electrical displays as well you can look at later. We've got an emergency generator magnet. You can see as I spin it, and there's a coil behind it, not even touching it. We get an AC voltage coming out of it. And I ripped apart an old 150-year-old telephone, and we have a 100-volt AC generator over here. And the old telephones, you'd crank it up and say, Mabel, get me the fire department. That was what you were cranking inside the phone. Western Electric made them. You could probably still find them on the internet. So let's take a look at our centrifuge here. I'm going to turn the variac up slowly, and we can turn on a multimeter to volts and frequency. I turn up the variac. And you can see at approximately 3 revolutions per second, the inertia switch has tripped and turned on the emergency floor lighting. We'll do it one more time. Reset it. Turn up the variac slowly. And we get dozens of these in to test, and our mechanics are just amazed that we built this Rube Goldberg setup and the FAA actually bought it. We're the only shop on the planet, other than the manufacturer, certified to test these crash switches. So a lot of people know about us. There's a private internet for aviation. Everybody, literally every repair shop, and there's about 10,000 of them, is on this private network. So you can just type in who can fix this switch, my company will come up. Or they'll type in who owns these switches, and if we have them, we'll respond for price and availability. And that this private internet is so busy. I'll get 300 requests every day off this private internet for repairs and parts, and we'll maybe get maybe about 50 actual hits out of all those requests. So it's one crazy business we're in, and I've got 60 employees, and I'm teaching my high school physics to a lot of them, and it's a lot of fun.
So Steve, I'll have one next weekend, so you won't get as many requests.
And like I said, I have some other electrical. Let's turn on the Tesla coil. I've got a couple of comments about that. First of all, the Tesla coil is a 2-stage transformer. The primary transformer is running at 60 cycles off the 110 volts. The secondary transformer is 1 coil, 2 coils, 3 coils. The third coil is operating at a very high frequency. Let's see. And this Tesla coil puts out about 8,000 volts. You can see it'll light up a neon lamp. It's pumping electrons into the air. Or a fluorescent tube. Tesla thought he could transmit energy worldwide with something like this, but he really didn't know that air is an extremely poor conductor. You just can't transmit any amount of large current through the air. And I could also, draw the spark to my ring. That's about 8,000 volts, but very low current, microamps. And to my ring, it's spreading the energy over my entire ring, so it doesn't really hurt. But if it went like that, it would hurt.
Did you do that first bulb again?
What,
The
the neon?
Yeah.
The Uncle Festival.
So it's nice to use my high school physics at work. I still stay in touch with my high school physics teacher, who's 10 years older than I am. And we get together for these science fairs and to see the astronauts at the Space Museum. You should get there for that as well. That's it. You're all invited to come out and see us. We're a big shop, and this is just a tiny bit of what we do. We repair 100-pound generators, 90-kilowatt generators, hydraulic pumps. We do a test on an aircraft turbine starter, a starter for a Boeing 747. It's a pneumatic starter. It's not electric. It has a pinwheel in it, like a child's pinwheel. And the turbine wheel is turning at 90,000 RPM, incredibly fast. It's got a reduction gearbox that lowers the speed so it can start up a 747 engine. And we have to test it by hooking it up to a 300-pound steel wheel, and this wheel has to get up to 6,000 RPM in 30 seconds. That's the test. And it's behind 1-inch bulletproof glass. We don't let anybody stand next to it in case the turbine wheel happens to explode. We hope it stays inside the starter housing. So it's an amazing test to watch. As the air comes out of the starter and loses pressure, it turns into a cloud. So we have 40 psi of air going into the starter at a very high flow, and it turns that turbine wheel, and the air coming out forms 4 clouds coming out of the starter. An amazing thing to watch. I usually joke, when your Learjet needs a brake job, call me.
Excellent. Let's give Steve a round